Hi guys and girls, Mr. Hescox coming back to you again, talking more life science beginning principles. Your warm-up question of the day there is, what would you use to give the mass of a man? To give mass, the basic unit of the metric system is the gram, but there's a lot of grams, so we have to use a kilogram or 1,000 grams. Your metric measurement should be turned in from the Google Classroom. Today we're going to talk about the steps of the scientific method, and you're going to write some questions that we could experiment on. What is the scientific method? So science is a pursuit of answers. The scientific method is a systematic approach to finding the answers. So basically, it's a series of steps that we're going to use to make sure that when we find the answer, we're going in the right direction and we're following the right procedures. If you can think of any steps to the scientific method, what can you think of? Take a couple seconds to think about it. Most people are going to say questions, most people are going to say experiments, most people are going to say hypothesis. Now let's talk about what the steps are and what order they belong in. The steps of the scientific method are, the first one is to state the problem. So your problem has to be some sort of a question. What type of fertilizer makes my plants grow better? Then we're going to gather information. You don't want to run an experiment on plants unless you're an expert on plants. You need to go through and research and gather as much information as you can. Well, how do we research? We can start on the computer. We go to libraries. We read books. They used to make these things called encyclopedias, which have kind of become outdated, but they're very good sources of information. The other thing you can do for information is you can go talk to an expert. Maybe you're doing an experiment on plants, you go talk to a scientist who works with plants. That's another way of gathering information. Once you've gathered all of that information and you know as much as you can about your problem, you state a hypothesis. For years and years and years and years, seventh graders have always told me hypothesis is an educated guess. And I immediately say, what's an educated guess? Well, I don't know. An educated guess is a prediction. Based on your research, you think this will happen in your project. Once you have a prediction of what you think will happen, you need to find out what's going to happen. So you design an experiment. Your experiment's going to have two parts, a variable and control, that we'll talk about here shortly. While you're doing the experiment, we take observations and record data. These are measurements. You use graduated cylinders, you use rulers, you use thermometers. Then we organize and analyze the data into charts and graphs. We will make charts and graphs in here. We'll make them on your iPad or on a computer. That allows us to organize large amounts of data, make it very, very clear and very, very organized and very usable to other scientists. The fifth step is to state a conclusion. Your conclusion says, is your hypothesis right or wrong? It says the data that proves your hypothesis right or wrong, and it says where you could have went wrong. So maybe you realize that I didn't measure correctly. Maybe you think, oh, I didn't have the right amount of water in the plant that I had. Those would be places of error, and that would go in your conclusion. And then finally, you write that report. Writing a report of the conclusion is when you share this with the world. Scientists want to be published in what they call journals. A journal or a scientific journal is where you find something interesting and then you publish your paper on it. These are usually college professors or people going to be college professors or researchers. They publish their work so that somebody can use what they found to maybe further their work and maybe find new things about the world around us. There are two parts to an experiment. In an experiment, you have the control and the variable. And the experiment is always used to test a hypothesis. You cannot have an experiment without testing the hypothesis. Well, the control is the natural condition. The variable is what we change. There's actually two types of variables. You have an independent variable and a dependent variable. Let's say in an experiment we have some pots, and inside each pot we have a plant. Guess I'll make them green so they look like a plant. Each plant is given water, but one plant gets water and we need a better color than that. Miracle-Gro. So this type of experiment would be, does Miracle-Gro make my plants grow better? In this case, this watered plant is what we call the control, because plants naturally have just water. The plant that gets the Miracle-Gro is actually the specific independent variable. Over time, this plant may grow 2 inches, while this plant grows 3 inches. So the growth was different for our Miracle-Gro plus water plant. The independent variable causes the dependent variable. So the growth in this case is the dependent variable. It depends upon how much water and Miracle-Gro get. So in this experiment, where the water and the Miracle-Gro were given to 2 different plants, the Miracle-Gro plant grew better. Therefore, the Miracle-Gro caused a better plant growth. And then later on, we go back and we graph. This is one, maybe this is the other plant, plant A and plant B. And that is the independent, the control, and the dependent variable for our plants.